kids, welcome to today's maths class, and today we'll do centroid, orthocentre, lncentre and circumcentre of a triangle. Our learning objectives are altitudes of triangle, orthocentre, some important points and its various properties, medians of a triangle, centroid, some properties of the median and centres of triangle, perpendicular bisector of the sides of the triangle, circumcentres and circumcircle. So first is altitude of a triangle. An altitude of a triangle is the perpendicular line segment from the vertex to the opposite side. The line segment AL is called the altitude from A to BC. Here, this is the altitude. AL is the altitude from A to BC. Here it will make the 90-degree angle. Clear? In first, angle B and C, both are acute. Angle B and C, because one of the angle is 90 degree, so both other angle will be acute. L is the point of BC. Angle B, that is right angle 90 degree का angle है. L coincide with B. Here, in this, L coincide with B. In third, angle B is obtuse. Angle B, this angle is obtuse. L is the point of BC produce. BC को produce करेंगे and here it will make the 90 degree angle, so it is the altitude AL. Clear? The altitude AL is called the height of the triangle ABC with respect to the base BC. Every triangle has three altitudes drawn from the vertices of the opposite side of each. Next is orthocentre. Orthocentre is the point at which the altitude of the triangle meet. Orthocentre of right triangle lies at the vertex of the right angle. Whenever we draw the altitude where all the three altitudes will meet, that point is known as orthocentre. Some important points about the orthocentre. The orthocentre of an acute triangle lies in the interior of the triangle. Here, this is the orthocentre. It lies inside the triangle. The orthocentre of right triangle is the vertex containing the right angle. Here, the orthocentre of obtuse triangle lie in the exterior of the triangle. Here, it will lie outside or exterior the triangle. Next, some properties of the altitudes of an isosceles triangle. The altitude drawn on the equal side of an isosceles triangle are equal. The altitude on the base of an isosceles triangle bisected. The altitude of an equilateral triangle are equal. Next is median of triangle. A median of a triangle is a line segment joining the vertex to the midpoint of its opposite side. Vertex से opposite side के midpoint को जो line segment join करेगा, that is called the median. In the adjoining figure, D is the midpoint of side BC and triangle ABC, and AD is the median from the vertex A. Here, the AD, because D is the midpoint, so AD is the median of triangle ABC. Every triangle, three medians, one from each vertex joining to the midpoint of its opposite side. So, we can draw three medians. Next is experiment. We draw a triangle ABC, bisect BC at D and CA at E. Join AD and BE. AD and BE are the two median of the triangle. Let AD and BE intersect at G. Join CG and produce it to meet AB at F. Measure AF and FB. We find AF and FB are equal. Observe that the point of intersections of any two median lie to the third median as well. Repeat the experiment with the two more triangles. So like this is the triangle ABC. Now what we have done? We have bisect BC at D this is the midpoint, and CA at E. Now what we'll do? We will join AD and BE. Clear? So they will intersect at point G. Now what we'll do? We will join CG and produce it to F point. This is third median. So they will intersect at a point. Next is fifth file. Medians of the triangles are concurrent. Next is centroids. The point of the concurrence of the median of the triangle is called the centroid of the triangle. Point of concurrence means where the three medians intersect each other at a point. That is known as centroid. The centroid of the triangle always lies in the interior of triangle. To determine the centroids of the triangle, it is sufficient to draw two medians only. Their point of intersections give the centroid. The third median also passes through the point. Next, some important properties of centroids of medians of a triangle. The centroids of the triangle divides each one of the median into ratio of 2:1. Centroid that divide the median को 2:1 में divide करता है. The medians of an equilateral triangles are equal. The median to the equal side of an isosceles triangles are equal. If two medians of a triangle are equal, then the triangle is isosceles. Next, some important observations. The orthocentre of the triangle is the point of concurrence of its altitude. The median of triangles are concurrent. The altitude of the triangles are concurrent. The centroid, orthocentre and circumcentres and incentre of equilateral triangle coincide. The point at which the median of the triangle meet is called the centroid of triangle. Next is exercise 13.1. In the adjoining figure 13.5, triangle PQR is an isosceles triangle. PQ equals to PR. Draw medians QD and RE to the two equal side. So, this is the triangle PQR. Now we have drawn two medians QD and RE. Now we have to verify by measurement that QD equals to RE. So first we'll measure it with the scale and we'll see that QD equals to RE. Clear? So practice all the questions of this exercise. Next is perpendicular bisector of the side of triangle. A perpendicular bisector of the side of triangle is the line that is perpendicular to the side and bisected. Means 90 degree का angle भी होगा and it will bisect the line segment into two equal parts. In the adjoining figure 13.6, the line L is the perpendicular bisector of the side BC in triangle ABC. So this line L is the perpendicular bisector of the line segment BC. Here it will make the angle of 90 degree and it will divide the line segment BC into two equal parts. BM equals to MC. Clear? A triangle has three perpendicular bisectors, one from each side of the triangle. Experiment. We draw a triangle ABC. Draw the perpendicular bisector FO and EO of side AB and AC respectively. Let them intersect at O. From O, draw OD perpendicular to BC, meet BC in D. Measure BD and DC. We find that BD equals to DC and D is the midpoint of BC. Hence, OD is the perpendicular bisector of it. Repeat the above experiment with the two more triangles. We observe that each case the perpendicular bisector of the side of triangle pass through the common point. Here, we have constructed a triangle ABC. Now, what we have done? We have drawn the perpendicular bisector FO and EO. Clear? Which intersect at the point O. Now what will we do? From O draw OD. OD हम ड्रॉ कर लेंगे. OD परपेंडिकुलर टू BC. BC के परपेंडिकुलर ड्रॉ कर लेंगे. Now we will measure BD and DC. BD and DC. So we'll see they are equal. So that means OD is the perpendicular bisector of BC. Next is circumcenter. The perpendicular bisector of the sides of the triangles are congruent. The point of concurrence of the perpendicular bisector of the sides of triangle is called the circumcenter of triangle. Experiment. Draw a triangle ABC and the perpendicular bisector of three sides. Let them meet at O. Join OA, OB and OC. Measure OA, OB and OC. We find that OA equals to OB equals to OC. We will see that OA, OB and OC जो है that are equal. With center O and the radius OA, draw the circle passes through A, B, C. Thus OA equals to OB equals to OC. Next is fact file. The perpendicular bisector of the sides of the triangles are congruent, that is meet in the point. The circumcenter of the right triangle coincide with the midpoint of its hypotenuse. The locate of circumcenter of triangle, it is sufficient to draw the perpendicular bisector of any two sides of the triangle. Next is circumcircle. The circle passing through the vertices of the triangle is called a circumcircle. Radius of the circumcircle of the triangle is called the circumradius. Next is angle bisector of a triangle. Angle bisector of a triangle is the line segment that bisects an angle of a triangle and has its other end on the side opposite to the angle. The triangle has three angle bisector, one of each angle of triangle. Experiment. First, we'll draw any triangle ABC. Draw B, Q and C are the bisector of angle B and C respectively. So, this is the triangle ABC. Now, we have drawn two angle bisector. This is the bisector of angle B and this is the bisector of angle C. Let them intersect at L. They will intersect at the point L. Now, join A to L. That meet BC at P. Now measure angle BAP and angle CAP. We find that BAP equals to CAP. Angle BAP that is equals to angle CAP, means these two angles are equal. Repeat the experiment taking more triangles. In each case, we find that three angle bisector of the triangle passes through the common point. Next is fact file. The angle bisector of the triangles are congruent, means they will intersect at one point. Next is in-center. The point of the congruence of angle bisector of the triangle is called in-center. Fact file. The in-center always lies in the interior of the triangle. The in-center of the triangle is equidistant from its side. Next is in-circle. The circle touching all the sides of triangle is called in-circle. Radius of the in-circle of triangle is called the in-radius. Next is exercise 13.2. Draw a triangle ABC, side AB 5 cm, B 70 degree and BC 6 cm and find its in-center. So, first we will draw a triangle AB 5 cm. At B we will draw an angle of 70 degree. Now B as a center, 6 centimeter radius, will make an arc, that is point C. Join C to A. This is our required triangle ABC. Now what we'll do? We'll bisect these 3 angles. So this point L, that will be the incenter of this triangle. Clear? So practice all the questions of this exercise. Here we end the chapter. I hope you understand it well. Now to practice it.